Okay, how we doing here? First thing I'm going to do as we get going on this is I'm going to rectify a mistake I made with the equilateral triangle on video 12. And then I'm going to expand my ideas and give you a challenge problem. Nothing big deal, but a challenge problem nonetheless, and see if you can do it. And tomorrow, I will do it on the whiteboard right here. Okay? So let me go back and follow my ideas, what's going on here, and let's see where we were yesterday. So we said that you're supposed to know in elementary school how to find a triangle as long as the numbers are nice, and we were using triples with Pythagoras, where the slant here was the hypotenuse of a Pythagorean triple. And then we did a little bit of work yesterday, and I was so anxious to show you how you get radical 3, I forgot to complete the problem. So let me explain it again and follow up these ideas with two other examples. So, yesterday I drew a perpendicular bisector. I put a little right triangle there, and I said to you that it's really hard to think of an object that's simpler than an equilateral triangle with a length of 1 on each side. So this way we take away the excuse that math is so abstract, I can't imagine what we're doing here. Sure you can. You imagine a simple little equilateral triangle with each side as 1. Now I drop the perpendicular, I divide it in half, and each side becomes 1/2. And now we use the theorem of Pythagoras, which you're supposed to be familiar with, and we get a squared plus b squared equals c squared, where c squared is the hypotenuse, or c, I should say, is the hypotenuse. And then we get 1/2 squared plus x squared equals 1 squared. Now you should take a close look at that. It works. It's the same thing that works with all the other numbers. You can square 1/2. 1 times 1/2 is 1/4 plus x squared equals 1. Now remember, and this is what I didn't make clear yesterday that I'm clarifying now, I'm only here finding the height. When I get this irrational number with radical 3 in it, that will represent the height. I didn't make that clear yesterday. So now I take the opposite of negative 1/4, and what you do on one side, you do on the other, and we end up with x squared. 1 minus 1/4 is 3/4. We put the hat on both sides, and we end up getting x equals radical 3. I can't do anything with that. It's not a perfect square, but radical 4, of course, is a perfect square, and I end up getting x equals radical 3 over 2. But what is x? X is the height. So if I just erase here very quickly, and now I find the area. If area equals 1/2 base times height, well, then in this case it equals 1/2. The base is 1 by definition, and the height is radical 3 over 2. So we get a final answer here of the area of any triangle you can think of where all the sides are equal, 1, 1, 1, is going to be radical 3, because 1 times radical 3 is radical 3, divided by 2 times 2, which is 4. And this is a remarkable finding here, that we take the simplest objects, apply the theorem of Pythagoras, and out pop these guys right away. Radical 3. So that's the area of any equilateral triangle where the sides are 1. There's no way of getting away from that. Another example. We'll keep the theorem of Pythagoras here. And I showed you this back in the fall, but let's do it again. Let's say we have a square, sides 1 again, to make the argument easier, and we want to know the sum of the diagonals. So, since it's a square, if I know one diagonal, I know the other. So I'll just calculate the diagonals and multiply by 2. But this is instructive for an 8th grader. Since the sides are 1, I can imagine a right triangle just like that. Just like that. And then I have A is 1 squared, that's one leg. B is 1 squared, that's another leg. And there's the diagonal over there. And that's going to be x squared. We give it the name of a variable. So, 1 squared is 1. 1 squared is 1. 1 plus 1 is 2 equals x squared. Same old trick. We put the hat on both sides, and it turns out that radical 2 equals, whoops, sorry about that. Radical 2 equals x, or put the way we like to think about it, x equals radical 2. Well, if this diagonal is radical 2, that means the other diagonal is radical 2. And now right away we come up to that property I was talking about. Radical 2 plus radical 2 equals 2 radical 2. And that's an answer. And that leads me to try to explain a couple things here. That the sum of the two diagonals of any square where the side is 1 is 2 radical 2. And there it pops up again in a question that seems so simple. Okay? And now I want to pose two questions for you guys. And you noticed here, I did this, I did this. Let's ask the same question down here. And we'll really ask two questions, an easy one and a more difficult one. And that I'll ask you to try as a challenge. So here we go. I have a cube, just like the die that you see every day. You can't complain that you've never seen an object like this. If you play dice, cube is a dice. We're just giving it a 1 to make the math easy, so we stress the concepts. So I have two questions. What is the sum of the diagonal of the faces? Of the diagonals of the faces. Of the diagonals, whoops, not doing so good here, working on it, diagonals of the faces. And that should be an easy one, because basically I did the work with you. I'll certainly do that tomorrow. And now the challenge, a more challenging question, but certainly not too difficult for an 8th grader, is what is the sum of the diagonals of this cube? Right there, sides 1. Like I said, the simplest math you can imagine, or at least I should say object, and I'd like to know what the answer is there. Think this, here we go, from a two-dimensional object to a three-dimensional object, and I'd like you to think about what I'm saying. I'm going to post this in a couple minutes, and I want to know what the sum of the diagonals is of this cube. I will solve this tomorrow. I'm putting it in my notes now. I'm trying to become more organized. You have to number everything, keep a close eye on everything. So in the problems I'm doing later today, I'll try to have everything numbered. And this, by the way, is video number 14. Okay, so we'll try to be a little more organized here. What is the sum of the diagonals of a cube with the side is 1? And I'm going to amplify these ideas as we go along because they're so important going ahead if we're going to start doing high school math. Okay, so there we go. Let me post this. I'll be right with you.